All right, so here we're going to revisit this idea of an explicit formula, but it's going to be specifically applied to this idea of arithmetic sequences. So if you'll remember from last week, an explicit formula allows us to find a given term of a sequence without knowledge of any other terms. Okay, this is the type of equation that makes it really easy for us to find the 170th term of a sequence, because we don't need to know any terms that came before that, right? We can just focus on the term number 170. And in our work here, we're going to use this equation. This is probably worth writing down, making note of. This is how we will always define our arithmetic sequences explicitly. Okay, remember that a sub n, this guy right here, is just another way notationally to describe a sequence, right? That's how we start to build an equation of a sequence. A sub 1, if you'll remember, is our first term. And then D is coming from above, the same idea, the same concept of this common difference. Okay, so we're going to go ahead and apply this formula to example 3 and then 4, where we're asked to write the explicit formula that describes each of these sequences. And then specifically in example 3, we're asked to use that explicit formula to identify a sub 17. So I think the best thing to do is kind of break this into steps. So our first step is going to be find or identify a sub 1. Okay, and unless otherwise stated, unless we're told or given information that would lead us to believe that a sub 1 is not the first term of our sequence, we can just grab that first term of our sequence. So here it doesn't say that 10 is actually the fourth term of our sequence. There's no ... before the 10, so we're safe to assume that a sub 1 is equal to 10. Okay, the next thing that we're going to need to do is identify the common difference, D. And we'll remind ourselves that D is just that number that is being added between the successive terms of a sequence. So it might be helpful just to copy the sequence down here. We have 10, then 15, then 20, then 25, and then we're told that this continues indefinitely. So I can see here that if I add the value of 5 to 10, I get my second term of 15. If I add 5 to 15, I get my third term of 20. And finally, adding 5 to 20 gives me my fourth term of 25. So here I can identify that my common difference is the value of 5. Okay, so we have all the necessary pieces to write this explicit formula. And I'll remind you that our explicit formula is a sub n equals a sub 1 plus our common difference times the quantity n minus 1. So our step 3 is actually going to be fill in our a sub 1 and D values to this equation here. Okay, so as a reminder, we found a sub 1, we identified that as being 10, and we found that our common difference was 5. So we'll go ahead and fill in these values, right? We have a sub n is equal to 10, our first term, plus our common difference, then times n minus 1. And here you kind of have to make a little bit of a decision. Do you want to simplify this explicit equation out, or do you want to leave it? You can really go either way. If it's a multiple choice situation, you might find that you need to do some distribution and some combining like terms. If it was a free response, this would probably be sufficient. I do notice that I'm going to have to use this equation to identify a sub 17. So since I'm going to need to do more work with this equation, it might be in my best interest to go ahead and distribute this parenthesis, right? Distribute that 5 to the n and the minus 1 and combine like terms. So that would give us that a sub n is equal to 5n, 5n plus 5. Okay, so that's part of the question that we were asked to answer. Identify that explicit equation, a sub n equals 5n plus 5. But then we were also asked to find a sub 17. And so if you remember from our work from last week, all that means is we're going to go ahead and plug 17 in wherever there's an n. So that means that a sub 17 can be found by taking 5 times 17 plus 5. Okay, and I believe, this is worth checking me, but I believe that that value is 90. Okay, so here we've concluded both parts of example 2. We have found that the explicit equation or the explicit formula is a sub n equals 5n plus 5, and then we use that to calculate a sub 17 here. Okay, we are asked to do something very similar in example 4. Again, we're given a sequence and we're asked to come up with the explicit equation, and then we're asked to identify a sub 30 instead of a sub 17. So a little bit of a change there at the end, but otherwise pretty comparable. So first step, let's go ahead and find or identify a sub 1. Again, we're not led to believe that a sub 1 would be anything other than that first term listed there in our sequence. So we can go ahead and say a sub 1 equals 9. Our next step is going to be to find the common difference d. Okay, like I did before, I'm just going to go ahead and copy this sequence down just to give myself a little bit more room. We have the sequence 9, common negative 1, common negative 11, common negative 21, and then this continues indefinitely. So in looking at that and also copying it down, I see that between 9 and negative 1, there's a difference of negative 10. Between negative 1 and negative 11, there's a difference of a negative 10 again, and yet again here between negative 11 and negative 21. So, oops. That difference between negative 11 and negative 21 is again negative 10. So we can say that our common difference is negative 10. So next what we can do is go ahead and grab those values and plug them in. So plug in our a sub 1 and our common difference to the equation a sub n equals a sub 1 plus d times n minus 1, right? So we're just going to substitute in our a sub 1 value as well as our common difference value. Okay, so in doing that, we find that a sub n equals 9. Here we have a subtraction, right, because our common difference is actually negative, so minus 10 times n minus 1. And again, since I'm going to continue working with this formula to identify a sub 30, I'm going to choose to go ahead and distribute and combine like terms. So this tells me that a sub n is equal to 9 minus 10n. Here we need to be careful, right? We have a negative 10 times a negative 1, so that will give us a positive 10. Combining our like terms will leave us with a sub n is equal to negative 10n plus 19. Okay, and that is part 1 of the question asked of us in example 4, right? That is identifying the explicit formula for the sequence that we were given. And we're going to go ahead and use that once again to go ahead and calculate a sub 30. So a sub 30 is just asking us what is our 30th term. So we're going to be plugging in that 30 anywhere we see an n. So a sub 30 can be found by taking negative 10 times 30 and then adding 19 to it. So we get that I believe is negative 281. So we find that a sub 30 is equal to negative 281. And again, we've answered both parts of example 4, right? We found our a sub n, our explicit formula here, and then we use that to go ahead and calculate a sub 30. Okay, so the last piece of this video is going to take you through example 5. Example 5 is a little bit challenging. It's a little bit of a puzzle, okay? And it's written out a little bit differently than how I'll take you through it on the video here than it is on your guided notes. So I encourage you to watch this video and also read your guided notes. But here I want to take advantage of the opportunity to give you guys a little bit of a visual of what's happening. So notice right away we have a big difference in the setup of this question, right? We're not given a list of numbers. Rather, we're given two numbers, right? We have, you'll see we have our first term, our a sub 1 term here, which is 5, and our 10th term, a sub 10 equaling negative 22. And we're asked to find the 100th term of the arithmetic sequence. So what this is asking us to do is it's asking us to figure out what is a sub 100. And if you look back on what we've done in example 3 and example 4, in order to answer a question like that, right? In example 4, we had to find a sub 30, and in example 3, we had to find a sub 17. Well, before we could just do that, we couldn't do that right away, right? We had to calculate a sub n. So we would need to find a sub n, our explicit formula, before we can find this 100th term. Okay, so in order to find the explicit formula, I'll remind you that we need to figure out what is a sub 1. Well, we were told that a sub 1 equals 5, so we've already found that. But we need to use the given information, it's going to be a bit of a puzzle, to find our common difference. Okay, so there's a little bit of groundwork that needs to be done before we can just go ahead and calculate a sub 100. So I want to give you guys a little bit of a visual, right? We have the sequence starting with 5, and then we have our second term, which is unknown, our third, fourth, fifth, sixth, seventh, eighth, 9th, and then our 10th. Okay, so we have a lot of blanks. We aren't quite sure what's going on there. But what I do know, and what is super helpful, is I'm told that this is an arithmetic sequence. So if I kind of connect back to my definition, that means that there is a common number that is added amongst all of these blanks. Okay, so if you notice, we have addition of some number, I'm going to call it D, 1, 2, 3, 4, 5, 6, 7, 8, 9 times, okay? So the value D, whatever that happens to be, is added 9 times over to take us from a sub 1, which is 5, and land us at negative 22. So I'm going to actually translate everything I just said into an equation. Okay, it's going to read 5 plus 9D, right? If I add the value D 9 times to the value 5, I'm going to get negative 22. Okay, now I'm in a situation that I can solve. I have a linear equation that I can solve. We, at this point, should feel comfortable subtracting the 5 over. We find that 9D equals negative 27. Dividing 9 on both sides gives us D equals negative 3. Okay, and that is the last piece of information that I need in order to write my a sub n, my explicit formula, right? I needed the value of D, and I also needed a sub 1. Okay, so we're going to go ahead and use this information and kind of guidance from examples 3 and 4, reminding us that we need to find, in order to find a sub n, we need our first term, a sub 1, plus our common difference times n minus 1. And we just found that, well, we were given that a sub 1 is equal to 5, and we just found that our common difference was negative 3. So we'll take negative 3 times n minus 1. And that is our a sub n value. But this question, if I'll remind you, asks you for a sub 100. Okay, so we can actually go ahead and plug in 100 wherever I see n. So we have 5 minus 3 times 100 minus 1. Notice I'm going about this a little bit differently than I did before. I've chosen not to distribute. Rather, I'm just going to go ahead and evaluate, which is fine. This will give me 5 minus 3 times 99. It's really important here to mind our order of operations, right? We can't subtract the 3 from the 5 because the 3 is being multiplied to 99 and the 5 is not. So what actually ends up happening here is we get 5 minus 297. And when we go ahead and take that difference, we end up with negative 292. So all of this work is to tell us that a sub 100 is equal to negative 292. So I know this example was a little bit more challenging given that we weren't provided a list of terms, right? Rather, we were given 2 terms and we had to use that to kind of do some problem solving, right? Some reasoning over here to figure out our common difference. But once we had our common difference and our first term, we were able to kind of proceed as normal, right? We were able to figure out our general or our explicit formula for our arithmetic sequence, and then we were able to plug in 100 to find that the 100th term of our sequence was negative 292. So if you're a little confused by this example, that's totally fine. I would encourage you to read the explanation and the guided notes as well. That might give you some different insights, and then definitely reach out if you have any questions.